Hi dear students, this is Vajidri Shah and today we are going in this video to explain electrical resistance, the concept of electrical resistance. Before this topic we have discussed the topic of Ohm's law. From there we have generated a concept of electrical resistance, and this is given on page number 69 in chapter 2 of the book. What is resistance actually? Resistance can be defined as the opposition to the flow of charges or current in a conductor is called resistance. Resistance is denoted by capital R or sometimes small r. The unit of resistance is, the system international unit is Ohm, after the name of George Simon Ohm, the scientist who presented Ohm's law, which is another manifestation of the law of conservation of energy. Equation for calculation of the resistance is taken from Ohm's law. R is equal to V divided by I. This is one equation used for calculation of the resistance of a conductor while performing an experiment of Ohm's law. What is actually the reason of resistance? The reason of the resistance is basically the collision between the moving electrons in a conductor because of electrical energy provided to the conductor with the lattice atoms. Collision between the moving electrons inside the conductor and the lattice atoms is basically the reason for electrical resistance. Some substances like copper, silver, zinc, etc. have very less resistance, and other substances can offer much more resistance depending upon their nature, their length, their area, their physical properties. Now, what are the factors upon which resistance depend? Factors affecting resistance. Numerically, mathematically, by experiment we can take one aspect of the conductor which increases or decreases the resistance of the conductor is basically the length of conductor. If we increase the length of the conductor, so we can increase the resistance of the conductor experimentally. Because by increasing the length of the conductor, we can actually increase the chances of collision between the moving electrons inside the conductor and the lattice atoms. So the first relation is resistance is directly proportional to length of the conductor. Second relation is resistance is inversely proportional to cross-sectional area of the conductor. The conductor which is having much more larger area for the flow of electrons in itself offering less resistance, because by increasing the cross-sectional area of the conductor we are actually decreasing the chances of collision between the electrons and the lattice atoms. And the third relation can be written, the third concept, which basically is related to the nature of the conductor. Nature of the substance, nature of the material, nature of the conductor. Like copper is considered to be the best conductor, zinc is comparatively weaker, and similarly silver is again another type of nature, so another amount of resistance. So Combining these two relations, these two mathematical relations, in a single relation or in a single equation, we can write that resistance is equal to rho L divided by A, where R is used for resistance and rho is a constant of proportionality, which basically is used here for resistivity. L is used for length of the conductor and A is used for the cross-sectional area of the conductor. Different materials have different values of resistivity. Now, what is resistivity? Looking at the above equation, as we know that R is equal to rho L divided by A, we can take the definition of resistivity from this equation like rho is equal to RA divided by L. Resistance of a conductor which is having unit length and unit cross-sectional area, the resistance of the conductor having unit length and unit cross-sectional area is called resistivity. Resistivity is basically a tool for identification of the different elements, different substances. So, resistivity is having the concept of resistance. In fact, resistance of the conductor having unit area and unit length is called resistivity. SI unit of resistivity is ohm meter square divided by meter. We can derive the unit for resistivity from the same equation. Meter is cancelled with one of the meters above, and finally the unit of the resistivity is ohm meter. We have a table given in the book, and the table basically describes the element and resistivity. Different elements have different values of resistivity, like copper. The detailed and complete table is given in the book, but I have written a few examples here. 0.0178 resistivity of copper. Similarly, aluminium, that is 0.0255. Again, tin, that is 0.114. Silver, 0.0163. Iron, 0.1. Micro ohm meter. These values are given in micro ohm meter. Ohm meter is the unit of resistivity and micro is a prefix. Again, we have another concept of the conductance. Conductance is basically the reciprocal of resistance. Reciprocal of resistance. We can write in mathematical form like conductance is denoted by capital G and it is reciprocal of the resistance. The material which are having much more resistance are having very less conductance concept. The materials which are having very less resistance concept are having a greater value of the conductance. As conductance is the reciprocal of the resistance, so the unit of conductance is again taken like MHO, mho, R, Siemens. Siemens is basically the name of a scientist, and this unit is inverted ohm, like we can write the unit of resistance as ohm. So conductance is the reciprocal of the R resistance. So we can take the unit of the conductance is again like the reverse of ohm. So we can read it like mho, MHO, R, Siemens as the unit of conductance, the system international unit of conductance. Another concept is conductivity related to conductance. Conductivity is taken as the reciprocal of the resistivity. Conductivity is taken as the reciprocal of resistivity. Conductance is taken as the reciprocal of the resistance. Conductivity is the reciprocal of resistivity. So, conductivity is again defined as the reciprocal of resistivity. Materials which are having higher values of resistivity will be having lesser or lower values of the conductivity, and the materials which are having very least property of the resistivity, so they will be having greater value of conductivity. Conductivity can be written in this form like sigma is equal to 1 over rho. Rho is resistivity and this sigma is used for conductivity. The unit of, as we have already written, like resistivity is equal to Ra divided by L. So if we want to take the reciprocal of resistivity, so we can write the equation for conductivity like L divided by Ra. The unit of conductivity is again, as the unit of resistivity is ohm meter, so we can write the unit of conductivity as MHO per meter. This minus 1 power shows per meter, denominator. So the unit of conductivity is mho per meter. R, Siemens per meter. We can write it again like MHO divided by M meter. R, Siemens per meter. So this is the unit of conductivity. We can use both of them. This is the unit of conductance. This is the unit of resistivity. And the unit of resistance is again shown like ohm. The unit of resistance is ohm. So that's all about the topic electrical resistance, or some related terminologies related to the resistance, conductance, resistivity, conductivity. If you have any question, any queries, you can ask. You can contact through a WhatsApp number or through Facebook or again through YouTube channel. And kindly don't forget to subscribe the channel which I have specially made for you because of this global pandemic. So thank you and Allah Hafiz.